Hello and welcome to day 1 of day 0 to break things. Today I'm going to smash this Lego set I'm hiding behind a blur filter by throwing it off this ledge onto the footpath below. You ready? Wait. What on earth does Lego have to do with vaccines? Let's rewind. Welcome back to another episode of Day 0 to Breakthrough. It's day 57 and I'm joining Elsje as she continues the process of receptor conformation. Last time we joined her, on day 38, she had incubated Q alongside the transferrin receptor to see if they bound to each other. The results of that experiment didn't show Q binding the transferrin receptor, so the team has a bit more investigating to do. Today, Elsje and the team want to see if Q and their other vaccine candidate, Z, bind to any other cell surface receptors. Remember, this is really important for a pandemic response. The better you know your enemy, the better equipped you'll be to defeat it. Elsje has been carefully growing her cell culture, which she is now collecting into one large sample with the help of Nick. One of the things they don't tell you about science is how much waiting there is. Once the cells were collected, they had to incubate for a while. This was the first of many long incubation steps. The receptors they are interested are locked inside the plasma membrane, which lines the outside of the cell. To do the receptor conformation, the team needs to get these proteins out of the membrane and floating around in an aqueous solution. Aqueous is just a fancy way of saying in water, so an aqueous solution is something dissolved in water. This is achieved using a very sophisticated technique that involves smashing up the cells using these funny-looking glass tools and a whole lot of detergent. This is another time-consuming and somewhat mindless task. Not all science is as glamorous as it seems. This was a nice opportunity for the team to make small talk. We chatted about our favourite TV shows, what we like to watch on YouTube, and Nick's cats. It was a good reminder that scientists are just ordinary people. While they might be doing life-saving medical research during the day, they go home and watch Stranger Things with their kids, just like any other parent. The now free membrane proteins are then run through a column, which is filled with tiny beads that are coated in our vaccine antigen, Q. Any receptor proteins that bind Q will get stuck in the column. All the others will flow out and be discarded. Elsje will then collect only the proteins that bind to Q and prep them for a process called mass spectrometry. Now, we're just about ready to start smashing things. The reason I'm doing it is to demonstrate how mass spectrometry, or mass spec, will be used in the receptor conformation process. Before loading her samples onto the mass spectrometer, Elsje will break the proteins up into fragments called peptides. When the peptides are injected into the mass spectrometer, they'll be separated into droplets, each hopefully containing a single peptide. These droplets will then be launched past a magnet, which will bend the proteins because proteins carry charge. Some proteins are more charged than others. The more charge they carry, the more they'll be bent by the magnet. The size of the protein will also affect how it bends as it moves past the magnet. Bigger proteins tend to be moved less. So, when the proteins are bent and hit the detector, the pattern will reveal both the size and the charge of the protein, which is something called the mass to charge ratio. From the mass to charge ratio, the team will be able to work out which proteins are present in their sample. For my demonstration, I'm going to do the breaking up and the launching in one step, and gravity is going to be my magnet. Now, I only have one shot at this, so hopefully it works. What you can see now is a rough approximation of what the mass spec data will look like. The big fragments haven't moved very far from the site where they hit the ground. That's the same as a big fragment not being moved very far by the magnet. The smaller fragments have managed to scatter themselves halfway across UQ lakes, which is the same as when you have a small protein fragment being bent a lot by the magnet. Hopefully from this pattern you'll be able to work out what unfortunate Lego set I threw off the balcony. Let me know in the comments what your guess is. Once the mass spec was completed, Elsje looked at the pattern of protein fragments and compared it with data from the literature. Q does bind transferrin receptor, but it also binds another protein called integrin, which was a bit surprising. These are the sorts of unexpected discoveries that make science really fun. Next time we check in, the team will be continuing quality checks on Q and Z as they move forward from day 0 to breakthrough. Catch you next time!